Have you ever pondered over the vastness of our universe? But what if we told you that it's not only vast, but growing every single moment? Indeed, our universe isn't a static entity but a dynamic one, continuously expanding and stretching like an infinite cosmic dance. This concept of an expanding universe isn't a recent revelation. It dates back to the 1920s and is credited to none other than Edwin Hubble. Yes, the same Hubble after whom the famous Hubble Space Telescope is named. His observations and subsequent research led him to the conclusion that our universe is in a state of constant expansion. Now you might be wondering, what does this expansion actually mean? Well, it's not as if the galaxies are just moving away from each other, rather it's space itself that's stretching. Imagine a balloon with dots on it. As you inflate the balloon, the dots move farther apart from each other. Similarly, in our universe, as space stretches, the celestial bodies within it move farther apart. The rate of the universe's expansion is measured in kilometers per second per megaparsec, a unit so large it's almost unfathomable. Current estimates fall somewhere between 67 and 74 kilometers per second per megaparsec. That's quite a speed, isn't it? And it's not just about how fast the universe is expanding, but also how this rate of expansion is changing over time. This phenomenon of the expanding universe is pivotal to our understanding of the cosmos. It has spurred debates, ignited curiosity, and opened up new avenues of research in the scientific community. And it's all about grappling with the infinite, the unknown, and the constantly evolving nature of our universe. So every moment that passes, the universe grows a little bit larger. Intriguing, isn't it? If the universe is expanding, the natural question that follows is, how fast? To answer this, scientists measure the universe's expansion rate in a unit called kilometers per second per megaparsec. Now that's a mouthful, isn't it? Let's break it down. A kilometer, we all know, is a unit of distance. A second, a unit of time. But what's a megaparsec? It's an astronomical unit of length equivalent to about 3 million light years. So, when we talk about kilometers per second per megaparsec, we're essentially discussing how fast objects in the universe are moving away from each other over these astronomical distances. Now you might be wondering, how fast is this really? Well, brace yourself for some astounding numbers. Current estimates of the universe's expansion rate range between 67 and 74 kilometers per second per megaparsec. Let's put this into perspective. Imagine you're watching a space race between two galaxies. For every megaparsec they are apart, they're racing away from each other at a speed of up to 74 kilometers per second. That's faster than any spaceship we've ever built. It's faster than anything we're capable of comprehending in our everyday lives. This incredible speed is not due to the galaxies themselves moving. No, it's because the very fabric of space is expanding, stretching out between these galaxies, pushing them farther and farther apart. It's as if the racetrack itself is growing longer and longer, making the finish line recede faster than any galaxy can possibly reach. So, while you're comfortably sitting wherever you are, the universe around you is expanding at a mind-boggling speed. And this isn't just happening in some distant corner of the cosmos. It's happening everywhere, all the time. Imagine, as you sit here, the universe expands at a rate of up to 74 kilometers per second for every megaparsec. That's quite a speed, isn't it? The universe's expansion was not just a random guess, but a conclusion drawn from careful observation and interpretation. Ever heard of redshift? We're about to dive into a fascinating phenomenon that goes by this intriguing name. Redshift, essentially, is a shift in the color of light from distant objects towards the red end of the visible spectrum. But how does this tie into the expanding universe? Let's break it down. Imagine you're observing a far-off galaxy through a telescope. If that galaxy were stationary, the light it emits would reach us with the same colors it had when it left, but that's not what we see. Instead, the light is stretched out, moved to longer, redder wavelengths. This is the redshift. Now why does this happen? It's because the universe is expanding. Space itself is stretching, causing distant objects to move farther apart over time. As the light travels over these vast cosmic distances, it too is stretched, resulting in the redshift we observe. The bigger the redshift, the faster the object is moving away from us. This is how Edwin Hubble in the 1920s first discovered that the universe is expanding. He noticed that the light from distant galaxies was always redshifted. The further away the galaxy, the greater the redshift. This led him to the groundbreaking conclusion that the universe is not static, but rather, it's continuously expanding. So redshift is not just a curious quirk of light, it's a messenger from the cosmos, shedding light on the universe's grand-scale dynamics. It's like the universe's heartbeat, the rhythm of expansion echoing through the cosmos in the form of red-shifted light. The discovery of redshift sparked debates and drove further research in the scientific community. The rate of the universe's expansion is still a hot topic, with estimates currently falling between 67 and 74 kilometers per second per megaparsec. This ongoing exploration, fueled by the Redshift Revelation, continues to refine our understanding of the universe. So, the redshift in light from distant objects was the universe's way of telling us, I am growing. The discovery of the universe's expansion has been a game changer. It has profound implications for our understanding of the cosmos. You see, the concept of an expanding universe is not just an intriguing idea, it's crucial for understanding the evolution of the universe itself. This expansion means that space itself is stretching like an elastic band being pulled in opposite directions. It's causing objects like galaxies to move farther apart over time. This stretch isn't just happening in one direction, but in every direction, everywhere, all the time. It's a concept that can be quite mind-boggling if you really stop to ponder it. But the implications go even further. The rate of this cosmic expansion isn't stagnant, it's dynamic. It's measured in kilometers per second per megaparsec, with current estimates falling between 67 and 74 km/s/mpc. Sounds complicated, right? In simple terms, it means for every 3.25 million light-years further away a galaxy is from us, it appears to be moving 67 to 74 kilometers per second faster. But that's not because the galaxy is moving, but because the space between us and the galaxy is expanding. Now here's where it gets really interesting. The precise rate of this expansion has been a hot topic of debate among the scientific community. Why? Because it's not just about figuring out a number. It's about understanding the underlying physics that govern our universe. If our current understanding of physics is correct, then the rate of expansion should be predictable. But the observations don't quite match the predictions, which suggests that there might be new physics at play. It's a tantalizing prospect that could potentially change our understanding of the universe and its future. So, you see, the concept of an expanding universe is not just about galaxies moving away from each other, it's about the fundamental laws that govern our cosmos. It's about trying to understand the universe's past, present, and future. The expanding universe, it's not just a fascinating concept but a cornerstone of our understanding of the cosmos. So, we know the universe is expanding, but what does this mean for the future of our cosmos? Let's delve into the realm of cosmic speculation, where scientists have theorized fascinating scenarios for the future of our ever-expanding universe. Imagine a universe that keeps expanding forever, never slowing down, never ceasing its outward march. This is one possibility, a scenario known as the Big Freeze. Here, the universe would continue to expand at an accelerating rate, eventually becoming so diffuse that galaxies, stars, and even atoms might be torn apart. But what if the expansion doesn't go on forever? What if it slows down, halts, or even reverses? This brings us to another theory, the Big Crunch. In this scenario, the universe's expansion would eventually slow and then contract, pulling everything back into a singularity, possibly setting the stage for another Big Bang and a brand new universe. Yet another theory suggests a balance between expansion and contraction, a kind of cosmic equilibrium. This Big Bounce theory proposes that our universe is one in a series of many, each birthed from the death of its predecessor in an endless cycle of expansion and contraction. In the realm of cosmic speculation, there are also more exotic possibilities. Could our universe be just one in a multiverse, each with its own laws and properties? Could there be parallel universes with their own space and time expanding alongside ours? These theories, as thrilling as they might be, are all based on our current understanding of the universe. Future discoveries might confirm one of these scenarios, or they might lead us to entirely new theories about the cosmos's future. While we may not have all the answers yet, one thing is certain. Our universe continues to grow, and with it, our understanding and curiosity.